have here is we have a McElroy pit bull fusion machine. It'll do anywhere from 4-inch, and if you purchase and install some additional inserts, you can go all the way down to 3/4-inch pipe. It's a very nice universal machine. We have our heating surface. We also have our facing tool. This is an electrified facing tool. We're going to go ahead and we're going to do an example weld, butt fusion weld, of a 2-inch HDPE 3408 pipe. Pretty much an industry standard. I'm going to insert the pipe, which we have previously wiped clean. Guys, you want to make sure that your pipe surfaces are clean and dry. We recommend you wipe them down with a cotton rag or perhaps a paper towel. Again, making sure to the best of your ability that your surfaces are clean and dry. Next, we're going to check our high-low adjustment. We want to make sure that the pieces of pipe as they come together are equally matched. This one's pretty darn close. Okay. Next, we're going to face our pipe. Our facing tool has rotating cutting blades. We're going to place it in here and turn it on and bring the pipe together to the facing plate. And it's going to shave and square up the ends of our pipe so we have a very clean and good mating surface. It's important on a project that you may want to consider bringing your own power source, because if it's new construction, as most of you know, you're all sharing the exact same temporary power pole. You never know when someone may have come by and unplugged you. That can be crucial when you're in the heating mode trying to maintain a proper temperature. So now we're going to go ahead and we're going to face the pipe. Again, I'm going to turn the facing tool on and bring pressure to bear so that we're shaving the pipe until it stops. This has stops on the facing tool here and here. I'm going to go ahead and carefully remove the facing tool, place it back in this nice holder. It's important now that since you've cleaned the surface and you now have a nice square clean surface cut, you do not touch it with skin and leave any oil residue. It may compromise your weld. Okay. Now that we have faced our fusion surface area, we've wiped them clean. Again, it's important not to touch the surface area of the pipe with your fingers, getting oil on there and potentially causing a problem with your weld. We want to check the high-low fitting again. To do that, we're going to use a tongue depressor, just to make sure that after the surfacing of the pipe, we haven't changed that. That looks good. If you have accidentally touched that surface area when you're removing some of the scrap debris, again, you'll want to take a clean, dry cotton rag, perhaps paper towel, and again, clean the surfaces. Again, visually inspect to make sure you have a good surface which you're going to mate. That looks good. Next most important component is going to be our heating surface. The heating surface must be minimum of 400 degrees, maximum of 450 degrees. And the way you verify those temperatures is you use a temperature crayon or a temple stick. There's one that melts at 400 degrees, so when you scratch it on the surface of the heating tool, it should melt. You then want to also scratch on your 450 degree temperature stick. If it melts, you are too hot. Okay? Adjust your tool down and retest in the same procedure. We've already verified our temperature. We know where we're at. We're about 410 degrees. On each one of these heating tools, though, you will find a dial thermometer. Please never use that as a representation as to what your surface area temperature is for welding. It's just an indication to let you know whether you've got a warm tool or not. Certainly not accurate enough to do any kind of welding with. So we're going to take our heating tool, we're going to set it into place, we're going to bring some pressure to bear. I'll walk through that process here in just a moment. So now we have both surfaces of the pipe contacting the heating plate. It's important not to apply too much pressure. You can see here that I'm only using just a couple of fingers to apply a steady, light pressure. You want your heating tool to do the work for you. The pipe's going to be absorbing the heat. It's going to start to form a bead on the exterior of the pipe. If you apply too much pressure, you're going to end up with a cold weld, perhaps an imperfect weld in surface area, maybe even start to distort the pipe a little bit. So again, it requires very little pressure. You want the heating surface to do the work for you. What we're looking for is a bead to form on each pipe of about 1/16 of an inch, about the same width as a wooden matchstick. When we have achieved that level of a bead on each surface of the pipe, we're going to then retract the arm, remove the heating plate, do a very quick inspection of our surfaces to make sure they're not distorted, and we're going to bring them back and mate them. We're going to show you that in just a moment. The clicking you hear is the thermostat, as it's maintaining the surface area temperature of the heating tool here. Okay, it looks like we have a pretty good bead formed. We're going to retract the lever, put the tool back in its protective cover, do a quick inspection. We're now going to bring the two surfaces together, apply some light pressure until the bead rolls back and touches the pipe. Notice that I'm using very light pressure with my fingers. This pit bull machine has a nice device that will come up and hold it in place so you no longer have to remember to apply light pressure only. You let your weld set until it is cool to the touch. So you can keep your finger on that welded joint comfortably. So now we have removed the completed weld. It's again cooled to the touch. I want to point out that the bead is actually rolled back to touch the original surface of the pipe on both sides. Here's another weld where we actually have cut it into two pieces. As you can see, there is no seam between the two pipes. They are bonded as one. You will never ever be able to separate this weld. It is one piece now. You can also see the same kind of a bead conformation inside the pipe. Now we're going to show a couple of examples of improper procedures. This one, we do not have an appropriate high-low adjustment. In fact, it's quite a ways out. We're going to go ahead and make that weld. And since we're doing inappropriate procedures, what do we really care what the temperature is? That is one ugly looking weld. As you can see, our high-low adjustment is significantly off. Our bead isn't well formed. Less than an ideal weld for certain. Now we're going to show an example of another inappropriate and improper welding procedure. Excessive force, which is a natural tendency for most of us guys because more is gooder, right? So I'm going to apply far too much pressure not only during the melting but also when I go ahead and join the two welds together. Okay, we've got our bead formed. Didn't take long. Oh yeah, and you can see the concave of the surface mating area.